Hello friends, welcome back to Online Maths Up. We're gonna be solving this equation right here. So what we have is that x power x is equal to 36. So what is gonna be the value of x that will satisfy this equation? So this is just pretty much cool, and then just follow through. We're gonna be solving these in this video. Okay, so the first thing I want to do is actually to take the natural log of both, and of course that is one of the most basic thing to do, so that I can actually bring down this unknown to the base. Okay, so if I do that, I'm going to be having natural log of x power x is equal to the natural log of 36. Okay, so applying the law of a logarithm, which of course basically say that if you have natural log of a power b, you can actually write these as b multiplied by the natural log of a. Okay, so by implication, I'm actually going to be bringing down these x here, and of course if I do it, I'm going to be having x multiplied by the natural log of x is equal to the natural log of 36. Okay, so at this point, what we are going to do too, we're actually going to be using to solve this equation, or to simplify to get the value of x, is the tool we call the Lambert W function. I've talked about this function in so many of my videos, and of course you can also go online and then get more materials and get more information about this particular function. It's pretty much cool to solving this kind of problem. Okay, so we're actually going to be utilizing that to solve this, and just like I've always mentioned, if you actually want to apply the Lambert W function to solve any math problem, you want to present your function to be in the form of a exponential a. So once you're able to simplify your function to be in the form of a exponential a, that is when you can actually proceed to apply the Lambert W function. Okay, and of course once you apply that, it is actually going to collapse all of this stuff we have inside the bracket to be equal to a. So you see, it is a cool tool to solving so many of these math problem. Okay, so what I'm going to do to achieve this function here to be in the form of a exponential a is actually to find a way to represent this x in an exponential function format, and it's just pretty much cool to see that you can actually write x as exponential natural log of x, and of course you can see I haven't changed anything because exponential of natural log is equal to 1, and then 1 times x gives you x. So in place of x right here, I'm actually going to be writing exponential natural log of x. Okay, so from here, what I'm going to be having is exponential natural log of x, and then of course multiply by this natural log of x over here is equal to the natural log of 36. Okay, so moving on, if you see this function right here, it is this one is at almost looking like it. So what I'm just gonna do is to rewrite this one to be like to be in the form of natural log of x, and then multiply by the natural log of x, and it's still equal to the natural log of 36. So that way you can see that we've gotten our function right here to be in the form of a exponential a, of course, where a in this case is natural log of x. Okay, so now we can go ahead to apply the Lambert W function. Okay, that is Lambert W function of natural log of x exponential natural log of x is equal to the Lambert W function of the natural log of 36. Okay, so and just like I mentioned, all of these is just going to collapse to the natural log of x. Okay, and of course it's equal to the Lambert W function of the natural log of 36. Okay, so at this point, to be able to remove this natural log so that we can find the value of x, I'm actually going to introduce exponential. I'll just take the exponential of both sides. So I have exponential natural log of x is equal to exponential Lambert W function of natural log of 36. Okay, and then of course exponential of natural log is equal to 1, and then 1 times x is equal to x. So eventually x is now equal to exponential of Lambert W function of natural log of 36. Okay, so this is actually going to be the solution to this, but then you may also want to find out the decimal representation of all of these. You just need to head over to wolframalpha.com. There you can be able to use the tool right there to compute this stuff right there, and then of course when you check it, you're actually going to be seeing that approximately that is equal to 3.1356. okay, so this is the approximate value of s, which of course when you compute this stuff right there in wolframalpha.com you will get. Okay, so let me have your thought in the comment section. That is actually how you solve these kind of problems, and then let me know if you've understood the solvings, and like this video, subscribe to our channel for more updates, and I'm going to see you guys in my next video. Bye.